Howdy everyone, this is Ari Danish with Side Effects, and today I want to talk about setting up a simple top network. Specifically, I'm going to PDGify a spatial colonization network. So what do I mean by that? Well, I want to create these branching structures. A few years ago I took, or I should say I audited, a course from CG Society on VEX, and one of the weeks they had was the space colonization. And I thought this would be a really good example of how you could take something that's very sequential and make it really parallelized in PDG. So the goal for today is, one, to show the basic traditional setup of a SOP solver for space colonization, show how we could suck in a bunch of these things using the table SOP, using the for each loop, and then using the SOP solver to grow the solution. Now, I'm really not interested in space colonization, and we won't go into the details of it today. What I'm really interested in seeing is what parameters do I need to suck into a PDG network, into a top network, to convert this linear sequence into something that takes advantage of places where there's no dependency, so we could really parallelize the whole process and make it much faster. For those interested in learning more about space colonization, I highly recommend this article that you can find at this URL. It's on modeling trees with space colonization, and it really takes you through the whole process. So let's go through a traditional Houdini workflow before we go into PDG. So here's kind of the setup. You're working in the VFX department, and you have a producer creating a shot list of all these branching networks for all the different shows. And that shot list might be a CSV file, some type of text file. In addition, maybe the layout department is creating these cameras that will come into you, so you have cameras to do your renders. Today we're going to focus just on this part of the shot list going into the VFX department. So what does that shot list look like? Well, it's just a CSV, something that you made in Excel or Numbers, and it can have like the show name. And here I just picked all my coworkers that are in this team together, and maybe it has a camera number, colors, the amount of seeds. We'll talk about the algorithm quickly in the next slide, and the amount of food, the thickness of the bumper, and so forth. Again, today we're not going to do the whole big thing because we're just focused on understanding these PDG concepts. So the attributes we'll probably use is the show name, the amount of seed, and the amount of food. Maybe the camera. We'll see. So how does space colonization work? Well, it's pretty simple. We'll take that text file with the show names. Let's say it says PDG. We'll extrude it into a 3D type. Pretty easy, a poly extrude. We'll use an ISO volume. A VDE from polygons to convert it to a volume. We'll then scatter a bunch of points on it. And we'll scatter two things. We'll scatter the food and the seed, and we'll talk about that in a second. And then finally, we'll use the space colonization algorithm to convert and grow these branching structures. So what do I mean about food and seed? Well, just a highlight of the algorithm is you have a bunch of seed, that's the purple. A bunch of food, that's the purple, and a few seeds. It could even be just one. And you have this search radius, and you say, what is the closest piece of food for me? And you go and you eat that piece of food, you consume it, and you create a little line, a branch. Then in the next cycle through, you say, okay, what's the next closest piece of food? And you create another branch, and so forth until you have that whole tree structure. That's space colonization in a nutshell. So at the object level, we're going to have three objects. One is the food and seed generator. Remember, that creates the point cloud of food and seed, and it will be saved to the hard drive. The second main object is the spatial colonization generator that creates that branching structure. There is a third object that we will not be talking about in this tutorial because, again, our focus is just the concepts for PDG. But that third object was render line thickness. First, let's dive into the food and seed generator. I broke this out into two key points. Things that are driven by the CSV file, this guy up here, and go right here. And the second thing is the key logic points. So at the very top, we have the table import SOP, which is going to go fetch the file and then break it out into rows and columns of the different fields like the show name, the camera number, and so forth. Then we have a for each, and actually a pretty decently sized for each loop. That's going to go through each row of that CSV file. And it's going to go through those items that we showed a little earlier, this process right here. And the way it's going to do that is it's going to copy to the fonts. And yes, we could do it different than a stamp, but I just was lazy and made a stamp function here. So it's going to copy with a little H script each row's show name onto a font. Then it's going to go and do a poly extrude to get the thickness. It's going to convert it to a volume. It's going to see from the CSV file what the amount of food that we should be scattering and what the amount of food that we should be putting down and the amounts of seeds we should be putting down. And then it will merge it all and save it off to the hard drive. Now, key things here are in this for loop, we got to do it one show at a time, right? We go through the process, we pick up that row, we go through this whole thing, then we go and pick up the next show and do the whole thing again. There are no dependencies between the show named Ari and the show named Ken or the show named Richard. These could all be really divvied up into many cores and be done in parallel. But right now, that would be hard to do because we can't use a threaded for loop in SAS because we have nodes there that aren't verbified and thus don't qualify for a threaded SOP evaluation. So here is a key type of workflow that really lends itself to being converted into a PDG workflow to make it much more efficient, much faster, and utilize as many cores as you have. And that's a key thing again. Remember, I have right now in my spreadsheet, I believe 16 items. But once you set up a PDG, and I'll repeat this later on too because it's so important, is you set up your template, and really PDG is a template, and you might test it on 16 items, but then you can expand it. You can have another spreadsheet, the next one you run through that, it's 1,000 items, and nothing changes. It just works, and then just, again, through PDG scheduling, it will say how many cores do I have and try to be as efficient as possible. So the other object I have is the space colonization object. It brings in the point clouds from the hard drive. It splits them back into the seed and the food, and then goes in a SOP solver to actually perform the actual colonization. Okay, so if we dive into the SOP solver, again, if you think about it, it's a different type of for loop. Last time it was just going through each item in the rows for the CSV file. In this case, the SOP solver is a for loop going through each frame. So if we had 60 frames that we want to render for start the branch down here and grow the branch for 60 frames to make this Birgit's name, it's still kind of a for loop. Big difference, the big takeaway from here though is that in creating the point clouds, each show was independent of each other. In a SOP solver, we don't have that pure independence. We have, it's a solver, so that means that the current frame is always calculated by the previous frame. So there's a dependency on frames, the previous frame. But each show is independent of each other. So we could divvy this one up by each show on a different core, and just know each core has a dependency that it has to calculate the previous frame. And again, PDG will do that for you. Okay, now is the moment that you've all been waiting for. Let's go into Houdini itself and start building that PDG network. So here I am in Houdini, and you can see I have a file object we'll talk about later, and I got my food and seed generator that we have seen. If I turn on the display flag, you can see the point cloud with Steve in it. I dive inside, and it's exactly what I showed you before. Okay, and I do not have right now, I could just put it down, the geometry, and dive inside. I have a digital asset for space colonization, and I also created for the future a food and seed HDA. So here is my space colonization asset, and we're good to go. So I'm going to delete that for now because I'm not going to need the geo. Just wanted to show you that it was there. And the first thing I'm going to do is I'm going to go and drop down a top network. Then I'll dive inside, and it comes with a local scheduler already put inside, built in. And the first thing we have to do is we have to grab that CSV file. And the way we do that is we go and do a file glob. Now, my build right now is 17.5.159. By the time you watch this, file glob will be renamed, and I should show it to you. File glob will be called files from pattern. So when watching this tutorial and you hit the tab key and you can't find file glob, just realize that it's now or will be called files from pattern. Back in Houdini, I select the file glob, and what I'm going to do is I'm going to go to the glob pattern parameter. I'll click on the file chooser, go to my HIP, and I know that I have it under my text folder, the CSV file, and it was called shotlessbumper.csv, and I say accept. And let's run this. So I'm going to go here and say cook selected node, and what you'll notice immediately is it now has one work item. Okay, that work item is pointing to the file shotlessbumper. And if I middle click on that work item, you'll see that it has hip text shotlessbumper.csv. Cool. Now, this only said, okay, I know where the file is. It did not set up like the table SOP the rows and columns for me yet. So that's what we have to do next. So I'm going to drop down a CSV input. And if you notice, there's a bunch of nice utility operators to work with CSV files, but we just need the input for now. Now I'll wire it up, and it's going to say here, how many rows do you want to calculate? So in my case, I know that I want, I think, 6 rows. So I'll just enter the number 6 here. Or if you want to do individually, just hit the plus sign over and over again. And there's going to be key things here that you're going to have to fill out. The CSV column index. So again, if we go back to Keynote, to our spreadsheet here. So column 0, 1, 2, 3, 4, 5, 6. These are your columns. So it's saying which column do you want to work with. So let's say column 0 is show. So column 1, and it'll say, okay, what is the data tag for it? And I'll type show. And then 2 is the camera. And that was in column 1. Now, the show was a string, but the camera is an integer, so I'll have to change that to integer. Instead of me filling this all out through the magic of copy and pasting, I already filled it out. I'll just put this guy in, and you can see column 0, 1, 2, 3, 4, 5, and so forth. And I'll wire this up, put the render flag on there, and cook this node. And now I have, if you count this, 16 work items. Again, that's associated with every row of this CSV file is now becomes one work item that could be parallelized. Cool. The other thing to notice, if I go here and pick any one of these and middle click, you can see I have show Julie, camera 1, food amount 5, and I should mention made this simple for the producers. That would be 5 times 1,000, so it will actually generate 5,000 points, and the seed amount and the thickness. Now, when you're doing this, the colors do mean things. This magenta purplish thing is strings, green is integers, and this orangish yellow is a float. One more thing that I should mention here is that when I created these data tags like food amount and show color and camera and show, and again, if we look at it here, we can refer to any of these attributes that we created downstreams with just the @ sign like you're used to in Vex. So I could say @show color or @show or @food amount, and no matter where we are downstream, it will know what you're talking about and be able to pull that information. Before I continue, I just want to go back up to the object level and turn off the display flag for the food and seed generator so we don't get confused of what's being driven by these objects and what's going to be driven by the top network. So I'm going to dive back inside. And now that I have a row for each work item here, let's create the food and seed processing, or the point cloud for it. So I'm going to drop down an HDA processor to just process an HDA and wired it in. Now the first thing it's going to ask you here is the template node, and that is, well, where is that digital asset? And when I do that, I can go to my object level and I can look for that food and seed generator. And inside that, there is an HDA, generate food and seed, and I'll say accept. And what it'll do is it'll go and find where on your hard drive is that HDA, and that's where this guy's pointing to. Now I should mention to you that I showed you this whole nice network, but behind the scenes I collapsed that into a simple HDA that takes a show parameter, a thickness parameter, a food amount, and a seed amount. Just know that we already took care of that. So back down in the HDA processor, the other thing to notice here is it has automatically a output file name, and you can see right here the HD parameters that it brought in, like show, thickness, food amount, and seed amount. And we'll talk about that in a second, but let's go back here and just look at the generation of the output also. So that's kind of small, so let me see if I can make this bigger for you. Open up a text editor. So there we go. So it says, where is the PDG directory? Find me the geometry folder and the operator string and the PDG name to concatenate the whole file name. Well, I really don't care about the operator string. What I want to know is to identify this point cloud by its show name. So I can say backtick @show backtick. Now, why do I need these backticks? Because this will be a string. And so for the string to be evaluated, a string attribute, we need those backticks. So I'm just going to copy that and paste it. Now if I ran it right now, let's just do that because it'll run pretty quickly. You can see it created 16 work items. Guess it's not quite done yet. There we go, all done. And so far I've been middle clicking to get this information here. But if this is show Luke, this is show Ken, and so forth, I can also just right click and say task info, so I don't have to hold the middle mouse button, show name Julie. And you can see that has an output and so forth. But we could also go here and just right click and say view task output. And a geometry file should show up, and here's Julie. If we clicked on something else, there's Julie. And if we clicked on something else, there's Julie. Obviously something went wrong. And the thing that went wrong is in HDA parameters, right now it's hard-coded to the defaults. So I got to go here and change this to @show. And again in backticks because it's a string. And then the thickness, I could say @thickness, @food amount, and @seed amount. And again, remember, where do we get those variables from? Right here, food amount, seed amount, thickness, and show. So if I dirty this up and click selected node again, hopefully this time it will work all correctly. And let's give it a try. View task amount, output I should say. There's Brigitte. And there's Richard. And let's just verify here with task info. Let's see where there's task info. And yep, it's Richard. So everything's corresponding. Everything is working just fine. Now, can I have kept it as a SOP network instead of making this food and seed into an HDA? Yes, I could have, and then we'll see on our next step for space colonization. But creating HDAs makes it so simple because I could just use this HDA processor to drive everything. And that's the key point here, is when I make it an HDA, I'm using these parameters to drive each work item. While we're here, let me show you a neat little trick. If you look at the scene view right now, there's nothing being displayed. And so far what I've been doing is I've been going here and saying view task output, which then launches a geometry viewer and loads up the results. It would be nice if we had some type of visualizer. And it's an easy way of doing this. Go back up to the object level, and I'm just going to drop down a file SOP. So there's the object, it's going to dive inside it. And here, I'm going to type in, let's go to Coda, @PDG output. Okay. And again, it's a string, so it has to be in backticks. I'll just copy that and place it in the geometry file. And suddenly I have a visualizer. If I go back into the top network and I select different work items, you can instantly see the results for that work item. That really makes life really slick. Now, just remember at the end, you're going to want to turn that off so it doesn't get rendered in your final render. I just want to show that there was no voodoo magic going on here. So in my TV bumpers folder, if I go into the geometry folder, you can see that I have the point clouds for everything being created. Now, there's just one food and seed here. These are the new stuff. So I kind of messed up on the file name. So I'm just going to go and change that HDA output to be correct. And it looks like that. Let me put that up also in here for you. So that's what I want. Geo, the show name, and just seed and food. This is only doing it once per item, right? We don't need a frame number or anything like that. So if I go back to Houdini, I'll stop the recording right now and just reprocess it quickly. So now you can see that I have file names like Julie Food Seed and Ken Food Seed and so forth. So that looks good, but I have this big mess here. And I should have showed you beforehand the correct way of doing this to clean up your mess from the previous run. So you can go always to tops and say dirty, delete all results from disk. Say OK. and it will go through your file and clean everything up. Now, I think it's too late because I already ran through another process, but that's how you would do it. Next step, let's create the space colonization. So this time, instead of using an HDA processor, I'm going to use a new operator within PDG called a ROP geometry. So let's put that down. And wire it up. And again, we'll use this for space colonization. And this is such a cool new node because basically you could dive inside and put any SOP network you want or HDA you want. And let me show you how that's done. So first thing I'm going to do here is evaluate single frame, yeah. And then where it says here use external SOP, I'm going to turn that off. See, when it's on, it's going to ask you to point to somewhere, but I'm going to just turn it off, and now I could dive inside. You see, right now it's errored out, and all I'm going to do is I'm going to go here and to my digital assets and put in my space colonization. And I'm having some interesting UI issues right now, so just bear with me. There we go. I'm just going to wire it in. And I could put in like at search radius, max points, and so forth, but I'm just going to leave it hardwired for now. And just run everything the same with the same parameters for these guys. Go back up. And again, it's going to ask me for a output file. Now this time, I'm going to want to run from frame 1 to 60. So I'm going to say evaluate using frame range. And it automatically puts in your frame range 1 to 60. And if you left click on this, you'll see it's just start to end, start fn. And it's going to ask for a name again. And what should we call this? This time probably show in backticks at show. So we still have the name. And this time we definitely need the frame number. And that should be about it. So now when I run this, dirty and cook, sorry, don't want dirty, just cook selected node, you're going to see we have a lot more frame work items. And the reason why? Well, it's now going to be 16 work items times 60 frames each. So this is going to take a little while. So let me go here and pause the recording until it's done. Okay, so it finished rendering all 960 frames that we're processing. And just got to remember, because we had that file geometry set to PDG output, it's looking at the final output of all our work items here. And so if I click on any work item, I could actually visualize what it rendered out. And obviously, I don't have 960 dots here. So if I want to see it further down the chain, I could come to the bottom of the little icon here, click on this, and I'll get the task graph table. And I could go just scroll here to any one I want. Like, let's find something further down the chain. And I could actually see through this what is being outputted. So this is frame 47 of Ari, and there it is. So great. That looks excellent. So I'm going to turn that off. And now what I want to do is I want to actually use Mantra to render it. But I don't want to render all the frames. I just want to render the last frame, frame 60. So what I'm going to do is I'm going to scoot this up a bit. And I'm going to drop down a filter by expression. And a filter expression is just what it says it does. I give it an expression up here, and it will filter it out. So I'll say at frame equals 60. And let's go to Keynote for a second. And I just want you to see Let's see, wrap geometry. I did type frame with a lowercase. I know that in Vex you're used to going at capital F frame, but in PDG it's lowercase. And again, if you ever need to see that, just go here into task info, look at what your names are here, and the attribute for frame, which is a float, is right there and it's in lowercase. So this is just an easy way to look up so what the actual names that you got to write down is. So if I were to go here and say hook expression, yes, save it please. I'm having problems today. It just cooked 944, and I should only had 16 because this 16 shows the last frame. And the reason here is I forgot to turn on invert filter. So I'm just going to go here and say dirty selected node and save. And again, I'm going to go cook selected node. And now I have the actual 16 items. And there they are. Pretty cool. We're ready to render. So let's just go and drop down the ROP mantra node. And you can see that the ROP mantra node is pretty much identical to a regular mantra node. It's going to ask you if you want to evaluate a single frame or a frame range. In our case, we only have these 16 work items. It's not a frame, it's just the end result. So you want to make it single frame. Then it's going to ask for which camera you want to use. And if you look up here, we have cam 1, 2, 3, 4, 5, 6. And if you remember from our spreadsheet, our CSV file, way back where, here, we just put the actual integer, 1, 2, 3, and so forth for the camera. So what we're going to do here is go and say, well, let's do it in here so you can see it. Object cam, and then in backticks camera, add camera, so it knows what camera we want. So I'm just going to put that right in there. And then it's going to ask us also what is our output file. And again, I'm going to show it to you here first. HIP to the render folder, the show name, and the PDG name. And the PDG name is because I need a unique identifier, and PDG name gives me that unique identifier. So imagine if I had two shows named Richard with different settings, like a different thickness and a different seed amount. In that case, one would clobber the other one when we're saving it. So by adding the add PDG name, we're making sure that it doesn't get clobbered and both shows get saved. So I'll just copy that. And I'll put it right here. And while we're there, I should mention, let's go back to Keynote, that there's a bunch of different things like PDG result is now being replaced by PDG inputs. So if you used PDG result before, use PDG input now. That's really hard to pronounce, I gotta say. There's a PDG index. Each work item always has an index number, but it may not be unique. So if you're expecting unique values, again, use something like the input. There's a log, which just is the log file of the upstream work item. And just remember this, that the PDG input evaluates the work item's inputs, and the output evaluates the work item's outputs. Why am I bringing that up right now? For the next step. Well, we got this all set up to render, but what are we going to render? So if we go up here, and we have that file with the results, PDG output. Well, if we just change that to input, now we're saying take the upstream items and render them. So those will be the 16 work items. And I'll just save that, and we'll go to, so going up, going back to my top network, and let's see if this will render. And I'll pause the recording until it finishes rendering. Okay, it finished rendering. Let's see if it worked. View task output for a certain work item. That's looking cool. All right. So, That's the end of PDG a spatial colonization network. My dogs are happy that I'm finished recording, and I'll have another tutorial up in a few days on wedging particle streams. I hope you enjoyed it and come back for that next tutorial.